have to know what exactly is a heat engine. Where do you find a heat engine? In scooter there is heat engine. The engine is called heat engine. And in motorcycle there is heat engine. In truck, in bus, everywhere there is heat engine. Okay. What is the input for a heat engine? Input is either petrol or diesel. Okay. So there is a petrol or diesel. And output, what is the output? Output is obviously motion, kinetic energy. Okay. So input, petrol or diesel in case of heat engine. Okay. So you may consider a Toto. That is not a heat engine because that does not use petrol or diesel. That is not a heat engine. So by heat engine we understand the engine of scooter, motorcycle, means for which petrol or diesel is the input. Okay, those are heat engines. Okay, and output is motion, it's kinetic energy. Okay, so heat engine description. Let us consider simple engine, and I am considering a motorcycle engine. These are two wheels. In this you have petrol or diesel. Then there is a pipe that will allow petrol or diesel to a device called carburetor. This carburetor. Carburetor. What is done in a carburetor? In a carburetor, this petrol or diesel, for instance, let us take a motorcycle, I am considering petrol. In a carburetor, the petrol comes out in form of fine particles. How does that happen? Very simple, using the power of gravity. Okay, so you see tank is always at the top. Because of gravity, petrol will come down. And then it will come out through a nozzle. Okay, very small openings are there. So as it comes out, it will come out in form of fine particles. Okay, then these fine particles of petrol will mix with air. Okay, so there is an inlet. Okay, I'll show you that inlet. This inlet actually goes to air filter. Okay, because air has lot of dust in it. So that air must pass through a filter. Okay, in order to separate the dust and other particles. Because if you allow dust particles to go inside, then that will choke. These points will be choked. So this goes to air filter. Okay, then through this petrol is coming down, through this air is going in, and the two will be mixed. Mixed means this petrol is getting dispersed into very fine particles. The process is called atomization. Okay. But do not think that those will be dispersed in form of atoms. Not that. Petrol will be dispersed into very fine particles, and that dispersion will occur in air. Okay. So what do you have in the output of carburetor? You have finely dispersed petrol particle in air. Air means oxygen. That means this substance that you have in gaseous form is highly combustible. Okay, just imagine someone has sprayed petrol in this room. Okay, petrol sprayed in this room, floating in air. Then a small spark and the whole thing will blow up. Okay, so you have now produced a highly combustible substance. Okay, this combustible substance will go to what is known as an engine. This is the engine. Engine is basically a piston cylinder arrangement. Okay, so piston cylinder arrangement. This is the piston. This is the piston. And this piston is, this is actually engine. The thing that you find at the top is actually called spark plug. This is spark plug. Spark plug. This will produce spark at regular interval. Okay, this is the type of spark that you find in your gas burner lighter. Okay, small tiny spark is produced. That type of spark will be produced in the spark plug. And you find such things around the piston, such fins. Okay, you can say the engine, then you find such a mesh type of thing, or some type of cage type of arrangement. Find fins. These fins are designed on the outer surface of the engine in order to produce cooling. Because how is cooling produced? Cooling will be produced by flowing air, and that's why there are fins. I discuss it afterwards. Discuss about it afterwards. Then I have shown you the piston. This is the piston. So this highly combustible substance will enter. This highly combustible substance, they have entered by the motion of the piston. As the piston will go in outward direction, means away from the spark plug, it will suck that petrol air mixture in it. Okay, and then after moving away from the spark plug, the piston will then move in forward direction, because the system is such that the piston will move like this. Okay, so after it has gone away from the spark plug, it will go towards the spark plug, and during this step it will actually compress that air fuel mixture. Okay, so now that petrol and air mixture is compressed, and when at the instant when the compression is adequate, not maximum, because maximum compression will not give you the result that you desire for. When the compression is adequate, not maximum, is if you compress it to the maximum point, then power output will not be that much. That will down in high level. Okay, anyway, when the compression is adequate, desired component, right at that instant, a tiny spark will be produced in the spark plug. The system is such that a spark will be produced in the spark plug, and that spark will ignite the whole thing. Whole mixture will explode, and that sound the sound that you hear from outside. Okay, loud sound. So that is actually the sound of explosion. Due to that explosion, the piston will move backward, carrying tremendous power in it. This piston will move backward, and during this motion, the connection is such, it is actually connected to through gears and others transmission system. Okay, there are a lot of transmission system, there may be gear, there may be chain. I am not going to that, the mechanical discussion. Power of the piston carrying large amount of power, means the piston is actually going backward with tremendous power, and that will rotate this wheel. Okay, so again the piston has gone backward. Again, due to inertia of the system is such, the piston will move forward. As it will move forward, again it will compress. Again there will be an ignition. So this process will go on. Okay, and the wheel will go on rotating. This is a heat engine. So you have seen an engine, carburetor. What happens in carburetor? Air filter draws air, and the fins that I have told you. Okay, fins are there to produce air cooling. Okay, because due to this explosion, the engine will become very hot. So it requires cooling. That's why engine is always placed in the front. Okay, engine is always placed in the front, and you should not stop flow of air to the engine. Okay, so do not indulge in such silly thing. Someone, you must have seen placing a guard behind the front wheel. That rubber guard is placed. That is not desired, because that will cut the flow of air to the engine. That will reduce. So there should not be any such thing here. It should be in front. The front of it should be kept free totally, so that it can receive maximum amount of air for cooling. Okay, and if you find clogging in this space due to penetration of mud or other things, then you should at regular interval clear those cloggings. That is, you should expose the metal surface to air for better cooling. Okay. Anyway, this is a basic heat engine with with the knowledge of this basic engine. I will now discuss the second law of thermodynamics. Okay. Second law should be compared to the first law. What do you get from first law, and what will you know from understanding of second law? First law gives you what? dq equal to du plus dw. Okay, that means it tells you that out of a given amount of heat, how much work will be produced. Okay, so how much work will be produced out of a given amount of heat. That is learned from first law. But second law tells you, or second law deals with something totally different. It does not tell how much work will be produced, but it tells under what condition heat can be converted into work. Under what condition heat can be converted into work. Not how much work. How much work? That you have learned from understanding of first law. Second law, under what condition the engine will give you work. Okay, so first thing is this gives the conditions under conditions or required to be satisfied, in order that an engine gives work as output. This is the thing. Conditions. Okay. So, I'll now discuss those conditions. This is the engine. A body. Engine. And for this engine to give you work as output, there have to be two bodies. There have to be two bodies, and one body must be at a greater temperature than the other body. One body must be at a greater temperature than the other body. This body is at T1 and this body is at T2, and T1 is greater than T2. Okay? So second law, it is telling you that there have to be two bodies. Okay? And one body must be at a higher temperature than the other. The body which is kept at a higher temperature is called source of heat, source of heat, and the body which is kept at a lower temperature is called sink of heat. Sink of heat. Okay? So with these two bodies around it, the engine does what? Engine collects or draws some amount of heat from the source, means from the body at high temperature, it collects some amount of heat. That heat is supposed, so it is collecting, it is drawing heat from this, okay, and let this heat be Q1, that means it is drawing Q1 amount of heat from the source, okay. Then the engine will convert only a part of this heat as work. The engine will convert only a part of this heat as work. Only a part of this heat is converted into work, and the remaining heat is rejected to the sink, means body at lower temperature. Okay, so this is the engine, this is the source of it, this is the sink of it. Temperature of source has to be greater than temperature of sink. Engine does what? It collects or draws Q1 amount of heat from the source, and then it does some amount of work and rejects the remaining heat Q2 to the sink. So how much heat is converted into what? W equal to Q1 minus Q2. W equal to Q1 minus Q2. Okay, now let us understand the source of heat, sink of heat, considering a practical engine, that of a motorcycle. So in the case of a motorcycle engine, what is the source? What is the sink? What is the source? What is the sink? This is the motorcycle engine. This is the motorcycle engine. What is the source? Source is obviously the exploding air and fuel mixture, that exploding, okay, which has a very large temperature, high temperature. That is the source. So exploding air fuel mixture is the source. Okay, then some amount is converted into what? And what is the sink? Surrounding air. Surrounding air. Because ultimately the heat, the rejected heat goes to the surrounding. How do you know that rejected heat goes to the surrounding? Just sense the temperature of the silencer, extremely hot. So from the silencer, heat is going, it is dissipating in atmospheric air. Engine has also become hot. From the engine, heat is rejected to the surrounding air. So air and exploding air plus fuel, okay, and in between the rotation of wheel. Okay, so now I can draw this from air and fuel. It is collected by the engine, then a part of this goes into the rotation of the wheel, and then through engine and through the body of the silencer, with the silencer, through this it is being rejected. So this is the source, this is the sink, okay, and you get work. These two topics. So I have described an engine and the things around it, but I have not yet stated second law of thermodynamics. I have clearly written that it gives the conditions. Now what are those conditions under which this engine will give you work? There are two conditions. First condition, conditions for an engine to give work as output. First condition, number one, for an engine to do work, T1 must be greater than T2. That is condition. Means it tells you that if T1 and T2 they become equal, then the engine will not give you any work. Okay, so when will this engine, motorcycle engine, will not run the motorcycle? When the temperature of source becomes equal to the temperature of sink. What is the temperature? What is the source? Air, exploding air fuel. And what is the temperature of sink? Temperature of air. Now imagine a situation that temperature of air is also equal to the temperature of this exploding substance. In that case, the engine will not give you any work. Means it will not roll the wheel. Okay, that is one condition. Second condition is one, in order to for an engine to give work as output, T1 has to be greater than T2. T1 has to be greater than T2. Okay. Second, another condition has to be satisfied. Okay. What is that second condition? Second condition is the engine will not. The second statement, rather not the condition, it tells you that the engine will never convert 100% of the drawn heat into work. That means 100% of the heat or the entire heat that the engine has collected from this exploding substance cannot be or will never be converted into work. Other way of telling it is always some heat will be rejected. Means 100% conversion of drawn heat is not possible. Always some heat will be rejected to the surrounding. Okay, so these are the two things. There are a lot of statements you will find. Okay, but basically Kelvin statement and other statements, basically these two things, these are the two things. So you must know these two things, that it tells you that the engine will do work only when T1 is greater than T2, and secondly 100% conversion of heat is not possible. So always there will be some rejected heat. Okay, so 100% conversion is not possible. This is equally applicable to our body also. Our body is an engine. Is our body an engine or not? So what is the input? We eat things. Okay, and our body always said there is some rejection in form of stool and other things. Okay, we exhale carbon dioxide, other things. Always there is some rejection. Okay, so our body as an engine also cannot convert 100% of the input. Always there will be some rejection. So it is quite similar in this case. There will always be some rejected heat, and the two things have to be, two temperatures have to be different. Okay, so write the second point. No engine can convert entire heat that it has drawn entire heat that it has drawn from the source, in bracket, that is Q1, entire heat that it has drawn from the source, that is Q1 amount of heat. No engine can convert entire heat that it has drawn from the source into work. Always a part of the drawn heat, will be rejected to the sink. Always a part of the drawn heat, Q2, will be rejected to the sink. Okay?